This is a video on exercises on chapter 1.3 and we are continuing from page number 196 in the pre-calculus book. So this video we are going to continue working on the exercises and we are starting off with problem number 37. So the problem number 37 asks us to determine whether each function is even or odd. Or neither. As we did it in our previous video, we are going to continue doing the same thing over here. F of x is x cubed plus 3. Now, in order for it to be even or odd, you have to put the value of x as negative x and see if there is any change in the equation. So, if f of negative x remains as the same as f of x, then we can say the function is even. If f of negative x becomes f negative of f of x, then we can say the function is odd. So using this information, we are going to put the values of x as negative x and see what happens. So in this, if I plug the value of negative x, you get negative x cubed plus negative x, which becomes negative x cubed minus x. You factor the negative out from this equation, which would give you negative x cubed plus x. This shows that this function is odd because you go back to the original equation. Therefore, this function is odd. And if the odd functions are symmetrical with respect to the origin. Now going over to problem number, the next problem is number 45. Number 45 on page 196. And number 45 is also the same. F of x equals to 1/5 x raised to power of 6 minus 3x cubed. We are going to plug the value of x as negative x and see what happens to this equation. 1/5 times negative x raised to power of 6 minus 3x negative x square. Now, for the even power of a negative number is always positive. So you end up with x raised to power of 6, the minus sign stays, 3 and negative, again this is an even power which becomes x square. Now you see that this equation is same as your original equation. Therefore, we say that this function is an even function and it is symmetrical with respect to y-axis. And going over to use number 49 says 49. I have to again minimize my graph. I apologize for that. Let's see. Give me a moment. I'm going to be working on this. Let's see if we can see number 49. Yes, finally it showed up. Number 49. There's a light reflection. Okay, it's asking us use the graph to determine each of the following where applicable, use interval notations. Now this is the graph. So in this graph they're asking us, first problem is they're asking us the domain. Now let's change the page. Okay, so in order to do the domain, I don't know how to get both the pairs. So if you see domain is the values of x, you can see the function is the x values are going from beyond negative x from here to positive infinity. Therefore, you say the domain is from negative infinity to positive infinity. The next one is they're asking us what is the range of the function. Now, if you look at the graph, the range, the function is actually from -4 to, and we do not know this graph continues. So the range would be from -4, including -4 to infinity. So therefore you have range as -4 to infinity. Okay, and the next problem they're asking, what are the x-intercepts? So what are the points where the graph is intersecting the x-axis? It is intersecting at 1 and 7. Therefore your x-intercepts are 1 and 7. Number D, it's asking us what are the y-intercepts. You can see in the graph it is only intersecting at this point. Therefore your y-intercept is just 4. Next, they're asking us the intervals in which the function is increasing. Now when you're saying it is always respect to your x-axis, you can see it is stationary over here. Here the graph is decreasing, and from this point it is increasing. So this is a point from 4 to infinity, your graph is increasing. So it is increasing from 4 to infinity. Okay, now number F, this was E, number F is intervals where the graph is decreasing. Now let's bring back the graph. Now the graph is decreasing from this point to this point. So this point is 0, at 2 again 4. So the graph is decreasing from 0 to 4. And next is, that was G. Now go back to the intervals where the graph is constant. Here if you look at the graph, you can see the graph is constant at over here. So from 0 and beyond, below 0, it's all stationary. So it's from negative infinity to 0, the graph is stationary. And they're asking you the number where f is relative minimum. The relative minimum in this, because we can only see a portion of the graph, the minimum is at the point 4, 0, and the minimum value is -4. And what is the relative maximum of f? The relative maximum, you do not have a relative maximum in this function, because if you can see, this function is going up. There is no relative maximum. Now that was problem number 49, and we are going to stop this video over here and catch on to the other problems in the next video.